Welcome back to physics. We are in module 7. We're talking about momentum. And one of the things we need to talk about is the conservation of momentum. Okay. If you were with me with module 6, which I hope you were, I talked about a little experience I had with the butterfly. Driving up to Bear Lake through the mountains, and a bunch of butterflies were migrating, and one of them happened to hit me. It didn't turn out so good for the butterfly. But did that actually slow me down? Did that cause my momentum to go down? I know the momentum of the butterfly went up because it went with me. So let's switch to the other screen here, and let's start to do some math. First off, the formula for momentum is equal to mass times velocity. Remember, velocity is a vector, which means momentum is going to be a vector as well. I could be traveling 10 meters a second to the east or whatever. Okay. I believe I can't remember how fast I was going, but let's say 8.9 meters per second. Okay. I'm going to go ahead and calculate my total momentum before the collision. Okay. So this is before the carnage on the butterfly. Okay. So momentum is equal to, my mass is about 99 kilograms. Okay. And we're going to multiply that by the velocity. And I was traveling probably about 8.9 meters per second. I'm going to put some significant figures on this one because I doubt it didn't slow me. It didn't slow me down very much. Okay. So from this, let's get our calculator out. Pull it on down here. So we had 99 times 8.9408 meters per second. That gives us 885.1. I can't remember the rest. I'm going to pull this up top. 1392. 1392. And our units are kilograms times meters per second. Okay. So this was before. This was before our collision. After our collision, now because momentum is conserved, the momentum before and after have to be the same, but the mass did change. The mass increased. After, our mass went from, except for this has to be the same, right? I can't change that. So that means this time I'm going to be calculating for my velocity, because we had a change in velocity, which means I divide both sides by the mass. So velocity is equal to a momentum divided by mass. Okay. So our mass did go up. The butterfly's mass is somewhere around 0.0005 kilograms. So the momentum remains the same. So 885.1392, and this is kilograms times meters. Kilograms, not kilo-m. Kilograms. Meters divided by seconds. And our mass went from 99 to 99.0005, and that's kilograms. Okay. So again, we are calculating for velocity. Our kilograms cancel. Let's grab a calculator here. Now that top number is going to remain the same, and we're going to divide that by 99.0005, and that gives us 8.94075. Let's pull that back up. So that is equal to 8.94075. 407. Wow, that is just not, that's pretty close. That's meters per second. So there was, the butterfly did accelerate. Let's draw this, okay? So I've got me on my motorcycle, front wheel. Here I am, here's the seat. I'm not a very good artist. Here's my head. Here's the back tire, okay? And I'm going this way. And that poor butterfly is flying this way. And it just happens to fly in and get hit. Goes right inside my helmet, right? So when that happened, the butterfly in my direction of travel had no velocity, right? So it then went from 0 velocity up to 9.845075 meters per second instantly, okay? And that's how you calculate it, okay? If you have any questions, let me know. Don't forget, you can always drop me an email, or you can jump in on office hours. So glad you're here. Let's I'm gonna move this out of the way. Let's get back, and if you have any questions, please reach out to me. Talk to you later.